Let's go ahead and solve the problem number 5. An unknown element has three naturally isotopes. Sorry for this. Three natural isotopes. Calculate the average atomic mass and identify the element. Well, what you need to do is remember the formula. You need to remember this formula, and is that the mass of the isotope 1 multiplied by the fraction, put fraction because it's easy, plus the mass of the isotope 2 by the fraction plus the mass of the isotope 3 multiplied by the fraction equals the average mass. The formula works for 2, for 3, for 5, for 10 isotope. It depends how many we have, but the sum of all each one of them, the sum of all of the mass multiplied by the fraction has to give me the average mass of the isotopes. And that's the one on the periodic table. And that's how we're going to determine which periodic table. And that's how we're going to determine which element it is. So let's go ahead and start the calculations, right? And then we'll compare it to the periodic table. Now, the first thing I do is I divide all of this by 100. Why? Because it's easy to use the formula in the form of fraction. Because when you multiply, for example, the mass of 1 by the percentage, you need to anyway divide it by 100. So instead of using 93.26, we will use 0.93 to 6. So you see how we do it. The mass of the isotope 1, let's say this is 1, this is 2, and this is 3. Isotope 1, 38.9637 AMU. Remember, AMU is the same as the atomic weight of the element on the periodic table. Now we're looking at those now when the mole comes out in grams per mole, but it's the same thing, AMU or grams per mole. And this is because it's the conversion, that's it. So we got 38.9637 multiplied by 0.9326 plus 39.9640 AMU plus, I like to do it on the same, what happened here, plus, let's see something, okay, I guess this goes here, and this doesn't matter, we have the formula already, right? So let me rewrite it again. I don't know why it's doing this. So it's the mass of 1, and let's put fraction of 1 plus mass of 2 by fraction of 2 plus mass of 3 multiplied by fraction of 3 equals the average mass, the average weight, the atomic mass, you see, average atomic mass, the average atomic mass. This is the formula you need to know. So plus AMU plus, I'm going to put it on the bottom, the number, this is number 1 isotope, 2 isotope, and 3, which is going to be 40.9618 AMU multiplied by 0.06730. If you divide this by 100, it would be 1 and 2, 0.062 equals, you don't know. That's what we need to find out. So let's do our calculations, right? And I'll give you directly the average atomic mass. Doing all this, do it on you. Maybe the calculator is from a different planet. 38. So it's gonna be 38.9630 0.937 multiply by 0.9326 sorry guys, let me stop the video. Okay, I got here some of the calculation. I multiply the first isotope, the way this is, the 1, 2, and 3. The first isotope, I multiply this by the fraction. This by the fraction, which is 0.000, 0.0, okay, hold on. Is that if I do this, it's gonna mess up this. And I knew I was gonna do it. Okay, so we got here, right, 38.9637 multiplied by 0.0936, which is the fraction of this one, right, here. This one would be 1, 2, 3, 1, 2, 3. So we multiply this by this fraction and this by 0.0673. This is going to give you this number each one, and then we're going to add them, 3 of them, to obtain the average mass. So the average mass is going to be, right, 275 that plus, then we'll take care of the sig fix at the end, plus 0.04675 plus 36.33754662 equals 39. It's going to be 39.098. So the total here, 39.09895,155 AMU. Because if you multiply AMU by an exact number gives you an AMU. Now the number of sig figs you have here is 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So we need to give it in 5 and 6 sig figs. This is a percentage. This is an exact number. So it would be 1, 2, 3, 4, 5, but this, you're going to round it to 10. So this would be 90 instead of 89. So this would be 90. So it would be 990 AMU. Let's take a look at our periodic table. I think it's potassium if I remember well. So our periodic table says that potassium 39.0983. It's not exactly, but we know it is already. It's relative close. So this is potassium. And that is the answer. Let's go ahead and keep on going to the next problem. This is, remember something, if you got a symbol here, you're always going to write down Z, which is the number of protons. Z is number of protons, and it's the same as atomic number. Just remember this, I'm reviewing this. A would be the mass number, and it's always on top. Mass number. N is the number of protons plus the number of neutrons, which has a charge of 0. And the electrons are equal, the number of electrons are equal, electrons are equal to the number of protons when charge is 0. So if you have a negative charge, -1, you have one additional electron. I know some of you don't never additional electron, so you don't remember this formula, but I usually, what I explain is that the number of protons minus the number of electrons is equal to the charge. And an example could be, let's look at oxygen, which the number of protons is 8, minus the number of electrons, you don't know it, equals to -2, with a charge of -2. That means that the number of electrons in oxygen -2 would be 10. It has 2 additional electrons. Okay, but let's go back. That's one. What you need to know, you need to know this one. This, you need to know you need to know this, you need to know this, and you need to know this and this. Okay? Now if you have a number here, this would be a number. 1, 1 plus 1 minus 2. This would be the charge. Now don't get confused with this. The mass number is not on the periodic table. It's the mass number, it is not on the periodic table. Mass number not on periodic table. It is a number without decimal. No decimal. The reason is because it's very often that the students confuse mass number with average mass from the periodic table. And this is basically, yes, the mass, but it's the average of several mass numbers. This here is the atomic number, and is given by the number of protons. So when you see the periodic table and the element is neutral, this would be boron B, 5 protons, 5 electron, with charge 0. So let's go ahead and look at this. A certain ion has a charge of +2. The ion has 36 electrons and 50 neutrons. Determine the number of protons. Well, first of all, if the charge is +2, it means that it has two less electrons than protons. Okay, and let's look at this little formula that some of you don't understand, but I'll tell you why. Because here, okay, this one, number of protons minus number of electrons is equal to the charge, in this case +2. So you have 36 electrons. How many protons? You don't know. This is your known. Minus 36 electron equals +2. So if you add 36 on both sides, would be 2 plus 36. How many protons are you going to have? 38. So you're going to have 2 additional, you're going to have 2 less electron than protons. So it's going to be 3. Number of protons is 38. Now mass number. Remember, mass number is equal to the number of protons plus neutron. So what is the number of protons? 38. What is the mass? The number of neutrons is given here, 50. So it would be 38 by 15, 8, 88. The mass number. And what would be the atomic number? Atomic number is equal to C, and is the number of protons, guys. Okay, here it says Z is equal to the number of protons and is equal to the atomic number. So it's gonna be C. I don't know why this is doing this. This is horrible. So here the mass number, okay, the number of neutron, letter A was 38. Letter B, I don't know what this is doing this. I can't move it because it's messing up everything. Let me rewrite it again. We already saw why 38. So the number of protons is 38. The mass number would be 88 because I add the number of neutrons, that is 50. And the atomic number is equal to the number of protons, which is 38. Okay, let's go ahead with the table. Now you know from the symbol that I told you, this is C, okay? And this is A. This is mass number, and this is atomic number. Now, in this, what is the mass number here? 32. What is the atomic number? Z. It's here, 16. Number of electrons, 16. Number of neutron, well, 32 minus 16, you subtract the 32 on top, minus 16, it gives me 16, right? And it's the number of neutrons. Number of protons is the same as atomic number. Don't forget, it's 16 and mass number 32. Here on this one, you got the number of neutrons, right, is 45, and the number of protons is 35. With the number of protons would be the same as atomic number 35. You can find out the element. This is a 35. And what would be the element for an atomic number of protons of 35? It would be bromine. Here it is, bromine, Br. I don't want to not even mess up with this. And what would be the number of neutron? 45. So the mass number would be 45 plus 35. It would be 80. 10, 7, 80 here. And what would be the number of electrons? Would be the same as the protons, 35. So here should be, if I can write here, 35 on bottom, 80 on top. Let me, bromine, on the left column, bromine, 35 and 80. Okay, so here, atomic number 12, let's look at our 12, which is magnesium. That is the element. So this is going to be magnesium because the atomic number is the same as number of protons, which is 12. Neutral atom, the number of electrons is the same as number of neutrons. So the mass number here is 24. And here is 12. So the mass number is 24, and the number of protons or atomic number is 12, which is the same. So how much is the number of neutrons? 12. Remember this formula where I told you that you had to subtract. You had to subtract 32 minus 16 in the other one. I can move this. This is driving me crazy. Let me stop for this for a second. Okay, let's start again. I wrote the formula and put it in another one. Let's see if now it works. I hope so. Okay, we got here, right? Number of protons, atomic number. Sorry, this is atomic number. This is mass number. A, mass number. And Z would be atomic number. Okay? And these are the formula, number. And these are the formula, number. I miss a... I hope it doesn't mess up when I erase now. This would be atomic number. And the formulas are here. So let's look at here. Here you got sulfur with number of electrons 16. It doesn't have a charge, so the number of protons equals the number of electron. Okay, the number of neutron, how can you find the number of neutron? You subtract, here it is, I put a formula here on this side, which is A minus C is equal to the number of neutron. A is on top, which is the mass number minus the atomic number. So 32 minus 16 gives me 16. So the number of neutron is 16. So what is the atomic number? The one on the bottom, which is the number of protons. Let's go ahead and look at this. Number of protons and electrons are the same in neutral atom, and it doesn't say it has a charge. Number of neutrons plus number of protons, gives me the mass number. So A is equal to 45 plus 35, which is going to be 80. Okay, 80 here. A number of protons is equal to the atomic number 35. So let's see what's the symbol for an atomic number. And protons of 35 is bromine. I did it before. So now we're going to go bromine, number of protons 35, and the mass number 80. Let's go ahead and look at the other ones. Atomic number is the same as number of protons, which is 12, and the same as number of electron in a neutral atom, 12 too. So number of neutron would be 24A, right? A minus C is equal to the number of neutrons. So number of neutrons would be equal to 24 minus 12, which is 12. So this is 12. And what is the element? We saw it already on the prior, and it's magnesium 12. So it's going to be Mg 12 on bottom, 24 on top. Now let's look, there's nothing here. It was a mistake here. So let's look at the number of electron 3. The number of protons would be the same because it's a neutral atom. And the atomic number is the number of protons, which is 3. Now what is the number of neutron? You got the mass number as 7, right? Here, which is A, minus the number of proton, or minus C, which is 3, equals 4. So the number of neutrons is 4. So here you got 3, and here you got 7. That's the mass number. You see it here? So now let's look at our periodic table, 3 and 7. It's lithium. Yeah, no, it was lithium, but I wanted you to see. Now let's look at the number of neutrons of 72 and a mass number of 120. We don't have this, we don't have this, we don't have this. But we know that if we subtract A, right? Okay, let's put it this way. You know the formula that the mass number A is equal to the number of protons plus the number of neutrons. We have to use these formulas to be able to find out what we need. And A we know is 120. We don't have the number of protons, electrons, atomic number, but we have this, we're going to call it unknown, but we have the number of neutrons, which is 72. So yes, you subtract 72 on both sides, and it's 8 for 48, right? 10, 11, 12, 48 should be. Yeah, 48. So you got here that the number of protons is 48, which is the same as the atomic number. This is the column for atomic number, right? And then the number of electrons would be the same as the number of protons on a neutron atom. So we got 48 here. How many do you have as mass numbers? 120. What is the element in our periodic table with 48? And 48 would be cadmium, and it would be CD. Okay, and that's for here. Now let's go ahead and do electron configuration. Let me check out the length. Yeah, I will stop it here, and the next video will cover the end electron configuration, the last three questions, which they are short. Okay, so